Let's understand the basics of programming using mathematics, which will ensure better understanding of the concepts. Let us consider the functions f of x or g of x. Those are the basic functions we will encounter when you see some math, right? Now, what is the value of f of 1 or g of 2? What? You look at me awkwardly. Say, what is the function f of x? I mean, what's its definition? Right? These are considered declarations. I mean, there is some function f of x and there is some function g of x. We are getting some declaration. Well, let's define it. Let f of x equal to x for x greater than 0 and minus x for x less than 0 and g of x to x for x greater than 0 and minus x plus 1 for x less than 0. Now what is the value of f of 1? It's 1, right? And g of 2 is 4, right? Similarly, in C programming, to use a function, it must be declared or defined. Once you define it, let's say, once you define a function like this, do you need to declare it again? Just like there is some function x. Do you need to mention it like this? No, right? We already gave the definition. Then there is no need for a declaration. So let's suppose we have a beggar around the street and you are the philanthropist. So you generally donate the money and you gave the money to the beggar. Are you expecting anything in return? Nothing in return. And similarly, there is a person who is working for a multi-billion-dollar company, and at the end of the month, what he is expecting? Salary, which is money. Here, he is expecting something in return, right? Similarly, a function may return something or may not return anything based on the definition provided. A basic function looks like this: return data type, function name, arguments, and definition. I mean the code, what the function does. So let's consider a typical desktop. What it contains: a screen, which acts as the output device, and a keyboard, which acts as the input device. Majority of the programs take input and process the information and give output. We need some functions to perform the I/O operations, right? We get some like standard functions for I/O operations, like to print some formatted data onto the screen, we use printf function. Similarly, for scanning formatted data, we have scanf function. Here F stands for formatted. Why it's called formatted, we'll see it in the upcoming videos. We want to use printf and scanf in our program, but we don't want to define it, right? We just want to dive into the program directly and don't want everything to write from the scratch, right? So there are something called as header files, which have the declarations like the above mentioned f of x, mentioning that there is some function f of x. Similarly, in stdio.h, there are a lot of IO function declarations that are present along with printf and scanf. So there are some declarations of these functions. so that we can use it directly. And the code is present in the archive form, which is magically linked to the code that is compiled, which we'll look at in the upcoming videos. Once we include it, we can use all the functions that are provided within the standard library. So, the problem or task is divided into subtasks. We define functions in such a way that when these functions are called in particular order, can solve the problem and also lets us reuse the code. It is called as modularity. So, we have functions fun1, fun2 and fun3. Since we have a lot of functions, we get the necessary to have a leader. We want our program to execute, but from where? From which function we should start, right? We got the ambiguity situation. To overcome these situations, we have something called as a main function. From this function, our program starts executing and invokes various other functions based on our requests. A main function may look like this: int main, a code block, and the code goes here. We are returning 0. We'll get into what are the primitive data types available in C in the next video. And that's it. Thank you.